In this tutorial, you are going to learn how to make two LEDs blink at two different rates and without using delay. So you probably already know the blink example, okay? I'm just going to put it there. So this is the minimum example that you have probably done when you got started with Arduino. And in this blink example, where you take one LED, so you set its mode in the void setup, and then in the void loop, you do digital write with high to power it on, and then you wait with delay, and then with digital write with low to power it off, and you wait again with the delay. The problem with that is the delay will completely block your program. It will block the execution of your program. So what if you have, for example, one LED that is blinking every 4 seconds, so 4,000 milliseconds, and you want another LED that should blink at, let's say, 257 milliseconds? Well, that's going to be very difficult to do. And that's what we're going to do in this tutorial, and of course, without using the delay function. So to be able to do this and to make two LEDs and actually any number of LED blink at any different rate, we are going to do for each different LED, we are going to do a 3-step process. Okay, I'm going to write it down here and then we are going to implement it for LED 1 and then for LED 2. So the first thing is we are going to get the previous time when we blinked the LED. So this time we are going to store it in a global variable. Second, we continuously check. So we continuously check if enough time has passed since previous time. Let's write this here. And third, if enough time has passed, we blink the LED, so we toggle the LED and update the previous time. And then repeat this structure for each action you want to do. So that can be blink an LED or do anything else, okay? So instead of using the delay function to block for a certain amount of time, we just store the last time we have done the action and then we check if we have spent enough time to do the action again, okay? So let's just write the code so you can better understand. So I'm going to start with first LED and I'm going to define LED 1 pin on pin number 12. So of course I need to initialize the mode, pin mode with LED 1 pin output. So that of course doesn't change. You have to initialize your LEDs. And then I'm going to create a variable unsigned long previous time LED 1 blink and initialize to millis or to 0. So in this variable, like the name suggests, we are going to store the previous time that when we blinked the LED. So whenever we blink the LED, we update this variable with the current time in millis. Okay, so millis will give you the current time. And so millis will return an unsigned long data type. So you have to use unsigned long here. So we initialize to millis, but actually this at the beginning of the program will be 0. So 0 or millis can be the same, okay? And then if we want to be able to check if enough time has passed, okay, this enough time, we need to define a time interval, okay, or a delay. So unsigned long, I'm going to name it LED 1 blink delay. And let's say that we want to blink the first LED at 1287 milliseconds. Okay, I choose a very random number. So every 1.2 seconds something. So this way we can compare between the time, the current time, okay, and the previous time and check if the difference is greater, okay, than the delay we use here. Okay, I use the name delay, but it doesn't mean we are going to use delay or that we are going to block the program, okay? So now we have those two variables. What we can do in the void loop, I'm going to do unsigned long time now is equal to millis. So whenever we enter the void loop, we get the current time with millis. And then what we can do, so we're going to toggle LED 1. So that is our first action. We're going to do if time now minus the previous time LED 1 blink. If this is greater than the blink delay, then we enter this block of code. So basically time now is, so this is a time, previous time is also a time, so when you make a subtraction between two times, you get a duration, okay? And the time now will of course always be greater than the previous time, so the duration of course is always positive. So this duration, you compare it to the blink delay. So at first, you have 0 here. When we enter the loop for the first time, the time now will be almost 0, okay? So 0 minus 0, we get 0. This is lower than this, so we don't enter the if. And then it's going to increase. So time now is going to increase until it reaches the blink delay. And when it reaches the blink delay, well, we are going to enter this if. So when we enter the if, what we are going to do, and this is important, we update the previous time, okay? So we can do the action. That is why we do this structure, so we can actually do the action, which is here to toggle LED 1, and we are also going to update the previous time. So previous time LED 1 blink. And what we are going to do, so what we could do is to say that the previous time LED 1 blink is equal to time now, okay? But what I'm going to do instead is to do previous time LED blink plus equal, which means that we just add something to the variable. We add the blink delay. So with this, because we add the blink delay to the previous time, the next time we are going to enter the if is of course 1287 milliseconds after that. So the time now will continue to increase, okay? And every time we reach the, so every time this duration is greater than the blink delay, we add the blink delay, okay? So we are going to wait for the blink delay to enter this block again. And this is perfect for what we want to do, which means that this action will be triggered every 1287 milliseconds. So now the action is to toggle the LED. So here we can't just do digital write high and digital write low like this. We need to store actually the state of the LED. So I'm going to add a new variable here, byte LED1 state, and set it to low at first. Okay, because when we are here, we don't necessarily know what was the previous state of the LED. So we need to store it here. And then what we do is we check if LED1 state is equal to high. Then what we do is we set it to low, is equal to low. And else LED1 state is equal to high. So here we toggle the LED state, and of course after we do this we have to do digital write LED1 pin with LED1 state. So this is the action that we do. We toggle the state in the variable and then we apply the new state to the pin. Alright, and that's it for the structure here. And now your LED1 will blink at this rate, okay, without actually blocking anything in the program. Because when you enter the void loop, it's going to just check this, which is very, very fast. And this will not be true most of the time. So it will just skip this. And when this is true, well, here, as you can see, we just change some variables and we just call digital write, which is quite fast. So that's going to be pretty fast and we don't block the program. And now that we have our LED1, which is blinking, we can do the same for LED2. So we just repeat the same structure. So the thing is that you have to understand the structure first. So that is actually the hard part, okay? Understand how to write this and how it works. And when you understand this, well, that is super easy because this is just the same thing all over again. So I'm going to remove all those comments here. And now you will see that will be super fast for the LED 2. So define LED 2 pin, which is on pin 11. I'm going also to initialize it now, pin mode LED 2 pin output. And so that was for LED 1. I'm going to put that here and put a comment LED 1. We are going to do the same for LED 2. I'm just going to copy this right there. So previous time LED 2 blink, which is 0. And then LED 2 blink delay, which I'm going to change it. I'm going to put 348. Okay, so I have chosen like two random numbers. Okay, so that makes it harder to use the delay function. Because for example, if I have put 500 and 1000, well, you could still do the blink for the two LEDs using delay. Okay, just using delay 500 and then toggle LED 2 and toggle LED 1 every 2 delays. Okay, but here that's not possible because you would have to find a common multiplier between the two, which is probably very big and will make your program super big just to write 2 blink LEDs. So we have here LED 2 state, which we also initialize to low. Great, and now in our loop, what we can do is here toggle LED 2, and I'm going to do the same thing if. So the time now, we are going to keep the same one, okay? Because this is super fast, so the time now will probably be the same here and here. Okay, so we don't need to get the time multiple times. So if time now minus the previous time LED 2 blink, if this is greater than the LED 2 blink delay, then what we do is first we update the previous time, so we add to it the delay. So next time we enter the if will be after this amount of time, and then we do if LED 1. So this is the LED 2, sorry. This is the action if the LED 2 is high, LED 2 state will be low. So I'm not optimizing the code here. This is really just to show you how to use the time functionality to blink 2 LEDs. Okay, but this of course can be optimized. Else LED 2 state is high. All right, and then we do, so we have our if, our else, and then digital write LED 2 pin with the LED 2 state. So as you can see, this block of code is the exact same one as this one. We just use different variables. And now if you have, let's say, 10 LEDs, well, you can do this 10 times. And actually, yeah, if you have 10 LEDs, maybe a best practice would be to use arrays. Okay, so you would use arrays so you can handle this better and write less code. But here, well, that seems to be pretty good. So now I'm going to upload the code to the Arduino. Let's name it blink 2 LEDs. And you can see the 2 LEDs blink at 2 different rates. Okay, so the LED 1 here, which is the red one, is blinking a bit more than 1 second. And the LED 2, which is the LED on pin 11, the green one, is blinking every 348 milliseconds. So we have 2 completely different blink rates. And the best part of it is that in the void loop function, we don't block anything. So here, after this line of code, we could do any action we want, and we would not be stuck by blink LED functionality. So now if you want to modify the blink delays for the 2 LEDs, you just have to modify one value here, and that will update all your program accordingly. If you liked this video, subscribe to get more tutorials like this in the future. Also, check out my online courses so you can learn Arduino step by step in an efficient way by practicing and directly going to the point. Links in the description. Alright, thank you for watching. See you in the next tutorial or in one of my courses.